Welcome back to Business Mathematics 2 MA 1203. So we are still going to discuss about second order difference equation. Now we are going to talk about the non-homogeneous second order difference equation with a special focus on the undetermined coefficient method. Are there any other method? Yes, there is, but it won't be discussed in this course. Okay, let's start. Look again, if we have this one, when GT is 0, we have the homogeneous, and when GT is not 0, you have a non-homogeneous one. When GT is constant, you have the steady-state solution. So this is just a generalization. Generalization if the GT is not just a constant. Okay, in this case, GT will only be a polynomial, okay, or exponential function. We will not discuss any other GT. We will not discuss any other GT. So the solution of a non-homogeneous difference equation, it consists of yt equals yt homogeneous. So you should seek the homogeneous solution first, plus the yt particular. Okay. Are there any steady-state solution here? Okay, the steady-state solution is included in this yt particular solution. Okay, okay, the particular solution depends on these two cases. Don't forget, this is the yt particular, or we usually call the general solution. If you are given the two initial conditions, you have the unique solution. Pay attention to the terminology. Be very careful. Be very careful. The particular solution depends on these two cases. Case 1, that is when GT doesn't contain homogeneous solution. Example is this. Okay, the homogeneous difference, the solution of this is just the essential function is 2 to the power of t and 1 to the power of t. Okay, and the GT is not a multiple of 2 to the power of t or 1 to the power of t. So this is the first case when GT doesn't contain a multiple of the homogeneous solution. What about this one? If GT contains homogeneous solution, what is the solution of this? You have the you have the characteristic equation r squared minus 1. So your solution will be 1 and minus 1. So yt should be 1 to the power of t times constant plus minus 1 to the power of t times second constant. So you have first constant, because 1 to the power of t is 1, first constant plus minus second constant times minus 1 to the power of t. So the constant is your homogeneous solution. So if your GT is just the same, is a constant also. So this means that your GT contains homogeneous solution, because your homogeneous solution, one of the homogeneous solution is the constant. Okay, the essential function, I mean. So in this first case, we let the particular to be the multiple of the essential function. So if you have the essential function, okay, 3 to the power of t, so you let yt particular should be a constant multiple of 3 to the power of t. And you can substitute this into your difference equation, okay, and you will find what is k here for the particular solution. And don't forget, your general solution is the homogeneous solution plus the particular solution. Okay, what about the second case? The second case, like the same as in the case when we have two essential functions that is the same. You remember, double root, you have to multiply with t. So if you have 5 here, and the solution this contains constant, so your general solution, the yt particular, should be constant times t, kt. Okay, then by substituting to the difference equation, we obtain k. Okay, let's see the example. So this is the first example. Find the unique solution. Don't forget, you have to find the homogeneous, the particular solution. The general is given by the homogeneous plus particular, and the unique solution correspond to this initial condition. Okay, let's start. First of all, the general solution is the homogeneous solution plus the particular solution. And you have to find first the homogeneous solution. So the characteristic equation is given by this. Don't forget, when we are talking about the characteristic equation, it corresponds to the homogeneous solution. And we have the factor of this is 3n minus 3. Thus, the YT homogeneous solution is given by k1 times 3 to the power of t plus k2 times minus 3 to the power of t. Okay, we have to find the particular solution. If you want to find the particular solution, because this is just a polynomial and the essential function is exponential function, so the GT is not the GT is not included in your homogeneous solution. So in this case, you will just use the general essential function of 4 plus t. Don't forget, this is just a polynomial or first order polynomial, first degree polynomial. So the general first degree polynomial will be at plus b or a plus bt. Okay, the general of this essential function. This is a polynomial of order 1. So your YT part should be a polynomial order 1 with two constants, a and b, a plus bt. Okay, and you can substitute this back into this, and you have this, yeah. Okay, yeah, this YT plus 2 is this. This is YT, okay, equals 4 to the power of plus t, and then you can simplify until you have this. Okay, because the last equation applies to all t in real, so you have the constant should be the same as the constant, and the coefficient of t is the same as the coefficient of t. So you have minus 8. B should be 1. So B should be minus 1 over 8. And 2b minus 8a equals 4. 2b minus 8 should be 4. And in the end, you have a equals minus 17 over 32. So the homogeneous solution, the YT particular solution is given by minus 17 over 32 minus 1/8 times t. So the general solution is given by this. Don't forget, we are talking about the unique solution. So you have to substitute your initial condition to get the unique solution. Don't forget, this is just the general solution. Yeah, if you have to find the unique solution, you have to substitute to find the K1 and K2 here. Okay, try it by yourself. Okay, the second example is when we have the GT is included in the homogeneous solution term. Let's start. So YT should be this, and finding homogeneous solution, the characteristic equation correspond to the homogeneous. This equals 0. So you have r squared minus 1 equals 0. So r should be this. And don't forget you have a constant. And this is just the same as this, because this is a constant and this is a constant. So your GT is included in the homogeneous solution. So what do you have to do? So here you have the essential function is just a constant. So your solution should be just a, constant a, but because it is included in the homogeneous, your particular, you should let your particular should be a times t here. Don't forget you have to multiply by t, And you can substitute this back to your original difference equation. And you have, why don't you have, okay, yeah, try this by yourself. And you substitute back, you have this, and the end you have a equals 2.5. And so the particular solution is this, and the general solution is given by this. Okay, yeah? Okay, try reading the textbook on the application, that is the cobweb model, the multiplier accelerator model, and price adjustment model. Try to read it by yourself, yeah? Okay, we will talk again about this on, I think we are going to talk about just one model, yeah? One or two model. The last model I will leave it to you. So you have to read the textbook. Okay, thank you very much.